The sine and cosine rules are rules that you can use for any triangle. The triangle doesn't have to be a right angle triangle, like the rules for Sokotoa. The sine rule has three parts to it. Sine A over A equals sine B over B equals sine C over C. You can use any two of those together. So I could use sine A over A equals sine B over B, or I could use sine B over B equals sine C over C, or I could use sine A over A equals sine C over C. What do all those C's and A's and B's mean? Well, on a triangle like this one down below, the capital A, the capital B and the capital C are angles. The lowercase a, the lowercase b and the lowercase c are sides, and you can put them wherever you like so long as the lowercase c is opposite the capital C, the lowercase b is opposite the capital B, and the lowercase a is opposite the capital A. The second rule, the cosine rule, says that a squared equals b squared plus c squared minus 2bc cos a. This rule looks a little bit like Pythagoras' rule, doesn't it? To use either the sine rule or the cosine rule, you must first of all label the diagram. So I'm going to start by labelling this side, this angle A, this side A, this side B, and this angle B. I don't need to label C or C because I'm not going to use them. So I'm using sine A over A equals sine B over B, and I just need to substitute. Sine 30 equals, or sine 30 over 5 equals sine 70 over B. If I transpose the equation, I'll end up with B equals sine 70 over sine 30 times 5, and that ends up being equal to 9.396 or 9.397. So to solve this, I've followed these steps. Label the diagram by putting A, B, A and B. Chose the rule, because I had A's and B's, I chose these two. Substituted 30 degrees, 70 degrees and 5 degrees, and then solved the equation, made B the subject, here it is, and then calculated the answer. Here's another example. Maybe you could stop the video and see if you can work it out before I show you how to do it. So, assuming that you've done that, I'm going to follow the steps. Label the diagram. So I'll call this big A, little a, capital A, lowercase b, capital B. And I'm going to try and find out what capital B is. So let's write down the equation. So sine A over A equals sine B over B, because I've got A's and B's, and I need to then, well, I've chosen the rule, so now I need to substitute. So sine 100 over 60 equals sine B over 40. So I'll rearrange that to make sine B the subject. So sine B equals 40 by sine 100 divided by 60, and the answer to that part is 0.6565. Now that's what sine B is, so we need to get B, so I do inverse sine of both sides, inverse sine of that side, inverse sine of that side. These two cancel, which is why we did it. So we end up with just B equals inverse sine of 0.6565, which is 41 degrees. Here's an example using the cosine rule. So again, I label a diagram. So this can be capital A, this can be lowercase a, and this can be C, and this can be B. So the rule is A equals B squared plus C squared minus 2BC cos A. So I'll substitute. A is x, so x squared equals b squared, which is 8 squared, plus c squared, which is 9 squared, minus 2 times bc, which is 2 times 8 times 9, multiplied by cosine of 40 degrees. So working that out, 8 squared's 64, 9 squared's 81. This bit on the end is equal to 110.31. So altogether that makes 34.69. So that means we've got x squared equals 34.69. Now we need to find x, so we have to square root both sides. On the left, the square and the square root are inverses, so I just end up with x. And on the right, the answer will be 5.89. So this example is a little bit different, so I'll label my diagram. There's an A here, a lowercase a here. This one can be B, and this one can be C. So if I substitute in, I'm going to get 7.5 squared for A squared, 9 squared for B squared, plus 7 squared for C squared, minus 2 times A times B, which is 63, cos A. Now, because A is the unknown, I need to rearrange the equation to make cos A the subject. But before we do that, we'll do a bit of tidying up. So 7.5 squared is 56.25, and 9 squared and 7 squared is 130, minus 126 cos A. Therefore, cos A is going to be equal to 56.25 minus 130 divided by minus 126, which is equal to 0.5853. So cos A equals that. So we need to do the inverse of cos to both sides. And on the left-hand side, the inverse and cos cancel each other out, and so we end up with just A equals inverse cos of 0.5853, which is 54.17. So here's a challenge for you to have a go at. Pythagoras' theorem is the hypotenuse squared is equal to the other two sides squared and added, which looks a bit suspiciously like this. The whole of the cosine rule can be turned into Pythagoras' theorem when one angle is 90. So I'd like you to show your teacher how to do that. The second one is the sine rule can also turn into the SOHCAHTOA rules when one angle is 90. So let's see if you can show your teacher that as well.